Right, so let's have a go at these past exam questions. The first thing we need to do is find the formula for methanol. Now you're given three options down the bottom here, and we just need to find the formula for this molecule here. You'll see there's 1 carbon, 1 oxygen, and 4 hydrogens. So we need to find the one here that matches that. This one doesn't match because it says there's 4 oxygens. These two are where people would trip up. You're never going to have to write a number above the writing. You're only ever going to write numbers below the writing, subscript writing. So this says 1 carbon, 4 hydrogens, and 1 oxygen. So this is the correct answer. What type of bonding is in methanol? Now, you should know from these series of lessons that it's going to be covalent, but if you didn't know, you go back here and you look at what type of elements these are. Carbon is a non-metal, hydrogen is a non-metal, oxygen is a non-metal. They're all non-metals, it has to be covalent. Methanol has a low boiling point. Why does this molecule here have a low boiling point? And it's because it's made of small molecules. You know it's not giant covalent structure. You'll learn about those a little later on, but they're things like diamond and graphite, graphene. And it has a metallic structure. None of these are metals, so it can't have been that one. Next thing, we need to draw the dot and cross diagrams for this molecule here. Hydrogen's already been drawn for you with a little circle. All you need to do is look at fluorine. Fluorine has 9 electrons, which means it's got 7 in its outer shell. All you need to do is draw those 7. The 7th one will be shared with hydrogen, so that hydrogen has got a full first shell. Remember, the first shell can only hold 2 electrons, so hydrogen's shell is full, 1, 2, by sharing this one from fluorine. And fluorine has got a full second shell with 8. 1, 2, 3, 4, 5, 6, 7, 8. The 8th one coming from hydrogen. We now need to look at this melting and boiling point graph. What is the state of oxygen difluoride at -200? So you go to -200, which is between -145 and -224. So it's in between here, which means above this boiling point, it will be a gas. Below this melting point, it will be a solid. So it lies in the middle, so it must be a liquid. If you get given a question like this, always draw a number line, because people mess up on the easiest things with the negative numbers. And even if you know negative numbers like the back of your hand, it's really easy to make these mistakes. So make sure you draw a number line. What is the change of state that occurs between -220 to -230? So -220, it is a liquid. -230, it is a solid. So what is it? It's freezing. Right, these are the questions that you see most often with properties of small covalent molecules, and it's asking why is it a gas or a liquid at room temperature. And these can range between 2 to 4 marks, as you might see in a minute. This one, so you have to be mindful of the marks. This is worth 3 marks, so you need 3 points. The way you'd answer this is you'd say, so there's weak forces between the fluorine molecules which require little energy to overcome or break, so to break those bonds. They're your 3 marks here. Now, if you were following the way I've been teaching you this lesson and the way that I'd be answering this, I would be saying weak intermolecular forces, and that is basically combining points 1 and 2 here. It's saying weak forces between molecules, so weak between molecule forces, weak intermolecular forces is 2 marks for that one, and saying which require little energy to overcome or break. You still need that for the 3rd mark.